So we're going to take a look at the half reaction method for balancing oxidation reduction or redox reactions. It's very simple, and we'll do this in acid media because that's usually the way it's going to work, and then we'll talk about basic media later on. So for starters, we need a reaction. So we're going to do the reaction of permanganate ions, which is a common oxidizing agent, with oxalate ions. C2O4 minus 2 is oxalate, and if you remember your oxidation reduction, we remember that in an acidic situation, I'm just going to put H plus here to indicate that it's acid. In an acidic situation, permanganate turns into manganese 2, and oxalate turns into carbon dioxide. So there's our unbalanced net ionic equation for this reaction. Now, for the half reaction method, we need to split this into the two half reactions that are going on. So the first one is the permanganate ion is going to form the manganese plus 2 ion, and the second half reaction is that the C2O4 minus 2, the oxalate ion, is turning into carbon dioxide. So these are my half reactions. This one here, manganese is going from a plus 7 to a plus 2, so that's being reduced. So this is my reduction, and C2O4 carbon is going in this case, so we've got 4 times minus 2, that's minus 8, so plus 6 plus 3 up to plus 4. So that's oxidation. So those are my two reactions. The half reaction method, simple. First step, balance anything that is not oxygen or hydrogen between the two sides. So manganese, I've got one of them here, I've got one of them here, that's fine. Here I have 2 carbons, so I'm going to put a 2 in front of the CO2 to give my 2 carbons there. That's it. Second step, balance the oxygens by adding water to the side that needs oxygen. So in my reductive half reaction up here, I've got 4 oxygens on this side and none over here. So in order to get 4 oxygens over here, I'm going to add 4 waters to that side. Down here, I've just balanced my oxygens. I have 4 on this side, and now because I put the 2 here, I have 4 here. So that one's done as well. Step 3, balance hydrogen by adding H plus, because we're in acid here, add H plus to the side that needs hydrogen. In my reductive half reaction, when I added the 4 waters, I also added 8 hydrogens. So to this side of the reaction over here, I'm going to add 8 H plus. There are no hydrogens in the second one, so I'm good there. Next step, balance the charge. So once I've balanced the hydrogens and oxygens, I need to balance the charge. The way I balance the charge is by adding electrons to the side of the half reaction that's more positive. So up here I have 8 positives and 1 negative. That's 7 positives up here. And on the right-hand side I only have 2 positives. So I need 5 electrons over on the left of this reaction, and that will make the charge on both sides plus 2. Down here, my total charge on the left is minus 2. My total charge on the right is 0, so I'm going to add 2 electrons down there. You should always check to make sure that the reductive half reaction has the electrons on the left, because reduction means to gain electrons, and so the electron should be reactant. You should also make sure that the oxidative half reaction has the electrons in the product side on the right, because oxidation is to give up electrons or lose electrons, and so you want them in the product side. Finally, we need to make sure that we have the same number of electrons on both sides. So I'm going to do this in red. And the way I'm going to do that is by multiplying one or both of these reactions by a whole number, everything through by the same whole number, to get the number of electrons equal. And basically I need the least common multiple of the two numbers of electrons. So I've got 2 down here, I've got 5 up here, that's the least common multiple is 10. In order to get 10 electrons up here, I'm going to multiply everything through by 2. So 5 electrons then becomes 10 electrons, 8H plus becomes 16H plus, this becomes 2MnO4 minus, 2Mn plus 2 plus, and 8 H2O. And down here I'm going to multiply everything through by 5. So I'm going to have 5 C2O4. This will become 10 CO2. This will become 10 electrons over here. So now we're going to cancel anything that shows up on both sides of my half reactions together, and I'm going to add them all back together. So I'm going to draw this little line here so that we can add them up. Now, what shows up on both sides? Well, the 10 electrons, those immediately go away, and the whole point of multiplying both reactions to get the number of electrons equal, the whole point of that was so that we could cancel them out, because we don't want electrons in our final equation. I don't have anything else that shows up on both sides. I've got H plus on this side, I don't have it here, no permanganate on this side, no oxalate on this side, and over here I've got Mn2 plus. So everything is fine, I just had to cancel out the electrons. Anything else that shows up on both sides, though, cancel it out, or cancel out an equivalent number of them on both sides. So then I just write what's left. So let's change the color again, if we can. We will go back to our blue color here. Okay, so what are we left with here? We have 16 H plus. We have 2 permanganates. We have 5 oxalates on this side. And on this side over here we have 10 CO2 and 2 Mn plus 2 and 8 H2O. And that is the half reaction method. That's how you solve and balance redox reaction. Now, this was done in acid because of the H plus. If we wanted to do it in base, we could do exactly the same thing. We pretend it's in acid. We get all the way to the bottom. And then we neutralize the H plus on both sides, or on either side, and we add hydroxides. So if we were to pretend for a minute that this equation was supposed to be done in base, it's not, but if we were to pretend, then I could cancel out, I'll use red here, I could cancel out the H plus by adding the same number of hydroxides. Now when I add 16 H plus and 16 OH minus, I get 16 water on this side. That gets rid of the H plus on this side. But whatever I do to this side, I have to add over here. So I'd have to add 16 OH minus to this side as well. And I've got nothing to react it with, nothing to cancel it out with, so it's just going to stay. But now I also have 16 water, and I have 8 water over here. So these 8 water are going to go away. These 16 water are going to become 8 water, because 8 of them will cancel on both sides. And now, if I re-add, so my 16H plus is now gone, it's now 8H2O, and still 2MnO4 minus, and 5C2O4 minus 2, and on this side still 10 CO2, and 2Mn plus 2. But now I don't have the 8 water anymore, I have 16 hydroxides. And so this would be balanced in base. Now it doesn't look right because, well, this reaction can't happen in base. Permanganate can't turn into Mn plus 2. If it's in base, it turns into MnO2, and it would give a different equation. But that's how it's done. So pretty straightforward. Just a reminder, go ahead and practice.